Discovering Alabama is a production of the Alabama Museum of Natural History.
Some say it was Alabama's greatest catastrophe. Experts believe the scope of destruction was so great that if it happened today, nearby Montgomery would be destroyed, as well as Auburn to the east and Clanton to the west, and perhaps even Birmingham well to the north.
Hi, I'm Doug Phillips, and you might say I'm standing on the edge of disaster. I'm standing on the edge of a crater that extends about 4 miles across and around the Alabama landscape. But what caused such a crater? Many scientists believe that this crater, known as the Wetumpka impact crater, was caused by a massive visitor from outer space. This program is about a land unknown to many people, a land that in many ways has escaped the hustle and bustle of modern civilization, a place of bountiful backcountry, forests, streams, and wildlife more diverse than can be found in much of the inhabited world. Come along with me as we explore the natural wonders of this land. Come along as we discover Alabama. Welcome to Discovering Alabama, and welcome to Wetumpka. Wetumpka is a picturesque, peaceful community that sits about at the fall line, which separates Alabama's coastal plain from the Piedmont region.
Along the steep hills of Wetumpka, visitors can easily collect mica, quartz, sandstone.
But wait a minute. Here along the fall line in this part of the state, you wouldn't expect to find this sort of steep hill country, much less metamorphic rocks.
This geological anomaly was first recorded by state geologist Eugene Allen Smith. Professor Smith traveled the state in a horse-drawn wagon, making the first geological survey of Alabama. On August 7, 1891, he noted the area around Wetumpka as structurally disturbed. More than 80 years would pass before another geologist would describe the impact of this structurally disturbed region of the state.
Well, geologists are always curious when something is out of the ordinary. And back in the early part of the 1970s, when my colleagues and I were mapping the east central part of Alabama, and we started getting closer to Wetumpka, and we started seeing hills. These are sharp hills with, strongly upturned or steeply upturned metamorphic rock. And anyway, that kind of prompted us to say, hey, we got something we don't understand. This is not typical of what you see in the crystalline rocks of the southeastern United States. Well, we spent, like I say, a good part of the fall of '72, I guess, walking, looking at the rocks. And the more we saw, the more we put on the maps, the more you realized, hey, this is starting to be a round structure.
Tony Nethery and his team recognized Eugene Smith's structurally disturbed anomaly as a crater. But what could cause such a crater? A first educated guess might be a volcano. Volcanoes can and do cause massive craters, yet volcanoes usually leave other evidence.
Well, there's no volcanic rocks out there. There's nothing in the rocks, in the geology of east central Alabama, say there was ever a volcano over there, not like you would think in terms of the western United States.
What the scientists found was something of a mystery. Here I have a bit of the soil that's normally found on the surface in this region of Alabama. And here are several samples of rock that are more typically found hundreds of feet beneath the surface. Around Wetumpka, something has drastically altered the landscape. literally turning the Earth inside out.
The rocks that we have brought up from below the surface here are very unusual. They have been shattered at great depth. And these shattered rocks are strong indication that there was the release of a tremendous amount of energy, as in the instance of an asteroid impact. Here at Wetumpka, we've never seen that shattered rock anywhere else in any drill holes in this vicinity in Alabama. This is remarkably similar to shattered rock that's been taken up from the Manson impact crater in Iowa, for example, and has been found at other craters around the world.
An impact crater. Many scientists now believe that an asteroid, a rather large asteroid, slammed into the planet right here in the heart of Alabama. But when Tony Nethery first reached this conclusion in the early 70s, the scientific community was not too quick to jump on the bandwagon.
When we wrote up the paper, we thought it was significant enough to write up the geology and turn it into one of the national geologic publications, science publications. Well, like I say, it went through the review process fine. You know, our colleagues reviewed it, said great, but when it got to the publication director's desk, I don't believe a word of this. This is hogwash. You know, it's not worth printing. And it took me the better part of about 2 years to just screaming and hollering, as you say, or jumping up and down, or just complaining that why didn't it deserve publication.
Though Tony Nethery's work describing an impact structure at Wetumpka was finally published, it would be another 20 years before interest on the subject would really take off.
This is a piece of the local bedrock, a metamorphic rock called schist. You can see the boundaries of the fragment here. This is a broken piece that has been brought up from depth and included in this outcrop as a result of the impact energy from the asteroid striking this area.
David King leads students on one of many field trips in recent years to visit the Wetumpka impact crater.
This is another piece of bedrock. It's a highly weathered fragment of bedrock. It looks almost red color. This also has been brought up from depth by the force of the impact. This is another piece of bedrock that has been broken off, brought up and included into this outcrop. It's a more dense metamorphic rock. It weathers almost a red color.
Where exactly would you find this rock in other parts of Alabama, or would you, this high up?
This is part of the local bedrock. It's found over a large area in central Alabama, but it's usually found at great depth, and it's very unusual to find a piece of it this close to the surface. And so that's the significance of finding this particular rock right here, is that it must have been brought up by some force, and we think that force was the rebound of the asteroid impact.
The search for definitive proof of an asteroid impact continues with help from Vulcan Materials. Drilling deep into the earth at the center of the crater, core samples are extracted that will be taken back to the lab for study.
Our involvement in this project came through our association with the State Geological Board and the State Geological Society. We're familiar with Dr. King and Tony Nethery, who were two of the lead scientists on the grant. They needed some drilling done to verify that this is an actual meteorite impact crater. And through our association with these people in the state board, our company decided to donate the drilling services. We're down 450 feet on this hole. We've hit bedrock around 400 feet. Our goal is to drill the hole 600 feet. That'll give them approximately 150 to 200 feet of bedrock material. And that should give them what they need to determine if this is a meteorite impact.
The drilling continues here at the center of the Wetumpka impact crater, a point which is also referred to as the Rebound Peak.
A rebound peak is formed when an asteroid strikes and then bounces back, lifting the ground with it. Looking up into the night sky at the moon, you can easily see the shadowy outline of impact craters punctuating the lunar surface.
With a telescope, you can spot the Rebound Peak at the center of the craters. The Wetumpka crater is not the classic bowl shape we typically think of. It is, in fact, horseshoe-shaped, indicating that the asteroid came in at a low or oblique angle, perhaps less than 10 degrees above the horizon. On the topographical map, you can see the highlighted horseshoe-shaped outer rim. The area highlighted in the middle is the Rebound Peak. Core samples from the Rebound Peak will be carefully labeled and studied, but it is not pieces of an asteroid the scientists will be looking for.
No, we don't find pieces of the asteroid. The object actually compresses as it hits the Earth's surface. And then after it penetrates into the crust, it starts to expand back into its original shape, but it can't retain that shape, and it actually vaporizes. And that's part of the explosion that is experienced by the asteroid hitting the Earth.
I'm standing on a steep hill just above Wetumpka, a hill known as Ball Knob. Ball Knob is actually on the northwestern rim of the crater. The water tower way in the distance is just beyond the northeastern rim of the crater. The northeastern rim forms the last ridge on the horizon, and it's about 4 miles away. This distance gives scientists a measure they can use to determine the size of the asteroid.
Well, there are a couple of ways to check the size of the asteroid. The simplest way is to take a very simple ratio of 20:1, the crater size, and divide that by 20, and you get the asteroid size. And this crater is about 4 miles across, so if you divide that by 20, you come up with about 1,100 feet. One of the useful things that I found to compare the asteroid size with is Jordan-Hare Stadium on the Auburn campus.
In East Alabama, they say the asteroid was bigger than Jordan-Hare Stadium. But over in West Alabama, they have a different measurement.
And see, the meteor that fell at Wetumpka, the size was at least as big as Denny Stadium, if not bigger.
No matter what you compare the asteroid to, it was big. And it was moving at a tremendous speed. It was probably traveling at about 12 miles per second, which is about the average velocity of an asteroid traveling through the inner part of the solar system. 12 miles per second works out to about 43,000 miles per hour. So when it hit, it created quite a stir.
It'll come in so fast that all you'll see will be this enormous bright flash. With the bright flash will come enormous heat. Everything will catch on fire to some great radius from the strike. Shortly thereafter will arrive a shock wave coming through the Earth, which will essentially be a giant earthquake in all directions, followed by a blast wave coming through the air, and a large noise. If you're far enough from it to have survived all of this, you will see an enormous mushroom-shaped cloud, or maybe even larger, simply a large dark cloud, which will ascend into the stratosphere and into the lower reaches of space, throwing an enormous amount of dust and material into the atmosphere, which may not come out of the atmosphere for years.
The Wetumpka asteroid created another problem for local inhabitants when it struck. At the time of impact, this area of Alabama was a shallow sea, and the violent contact would have produced a devastating tsunami.
We don't think that the layer of water significantly reduced the velocity of the object. Something that large, we think 1,100 feet across is the size of the asteroid here. Something that large, moving so fast, 12 miles per second, it probably didn't see the water. It just went right through the water layer. As a matter of fact, it probably penetrated several hundred feet into the crust before it exploded.
Water or no water, an 1,100-foot projectile traveling at more than 43,000 miles an hour is bound to have had a devastating effect on the local economy, you might say. Then again, things were considerably different around here at that time.
The way you get a relative age date for a crater is to find the youngest rocks that are broken up inside the crater, and we have located those, and those have fossils in them that indicate an age of about 83 million years. And so that's where that date comes from.
83 million years ago, during the late Mesozoic era, that part of Alabama which was not under sea was populated by giant reptiles. Many Alabama dinosaurs were no doubt killed by the Wetumpka asteroid, a violent, close encounter of the worst kind. Today, popular scientific theory holds that it was an even larger asteroid that eliminated dinosaurs from the face of the Earth. Scientists speculate that an asteroid 6 miles across struck our hemisphere about 60 million years ago with a release of energy 10,000 times that of the world's entire nuclear arsenal. This impact would have poisoned the air, heated the atmosphere, and created wildfires across the globe.
$60 million years. That's a long time, even for a geologist. And despite popular movies like Deep Impact, Armageddon, and Asteroid, the average person doesn't think too much about such invasions from outer space. But suppose you were resting on your sofa in the comfort of your own home when a piece of asteroid traveled millions of miles across the galaxy, exploded through your roof, and slammed into you.
As recently as 1954, a very bright meteorite came from the south and struck in Sylacauga. It was witnessed by people as far as 150 miles away. The thing broke into pieces in the air. One of the fragments came through the roof of Miss Ann Hodges' house, penetrated her roof, her ceiling, destroyed a cabinet radio, bounced off, and hit her as she napped on the couch. She was bruised but not seriously injured. But she remains the only human being ever legitimately to claim to have been hit by a meteorite. Another fragment of the same meteorite was found by a farmer named McKinney when it was laying in the middle of the road, and his mule wouldn't pass it, probably because it smelled like sulfur. So as we begin to look around us, we discover that meteorites are falling all of the time.
Before her death in 1972, Mrs. Ann Hodges donated the 8.5-pound meteorite to the Alabama Museum of Natural History. And here you can see the actual chunk of space debris that struck her.
Mrs. Hodges remains the only person known to ever be hit by a meteorite. But that's not to say it won't happen again. After all, there's a lot of stuff flying around out there.
8, 7, 6, 5, 4, 3, 2. We have engine started. We have ignition. We have liftoff of the Delta rocket carrying the nearest spacecraft bound for the asteroid Heroes.
We've ignited the other 3 solids, and all 6 of the first set are off. We have solid motor burnout, again very symmetrical. And we have solid motor jettison. All 3 of them came off cleanly. Attitude disturbances almost non-existent.
Asteroids are parent bodies of the meteorites, and we think that asteroids occasionally collide, and when they collide with one another, the pieces are thrown off into new orbits that cross the orbit of the Earth, and at that point they have a chance of hitting the Earth. They're primarily solid materials that are either a rock or iron. meteorites come from the asteroid belt, which is a swarm of many thousands of objects orbiting between the planets Mars and Jupiter, out beyond the orbit of the Earth. Comets are small objects that come primarily from the very outermost parts of the solar system beyond the orbit of Pluto. And at that distance, a comet can best be described as a big dirty snowball that might be, say, 20 miles across, 10 miles across. And these come swooping in through the solar system, and they also may strike the surface of the Earth, but it'll be much harder for a comet to survive passage through the Earth's atmosphere, or a fragment of a comet to survive passage through the Earth's atmosphere.
As recently as July of 1994, several fragments of a large comet known as Shoemaker-Levy 9 slammed into Jupiter, granting Earthlings a first ever look at such a collision of two solar system bodies. This NASA animation gives us an idea of how that encounter looked from outer space.
In 1908, an incredible explosion occurred over Siberia. Scientists believe this explosion was caused by a comet or meteorite bursting in the atmosphere. The blast destroyed 800 square miles of forest.
This event in Siberia was equivalent to about a 10 megaton thermonuclear blast. But that was small potatoes compared to the Wetumpka event at about 1,500 megatons. The town of Wetumpka gets its name from an Indian word meaning rumbling waters. David King speculates that the unusual rock formations created by the asteroid impact caused the waters to rumble, giving origin to the city's name. In the early 1800s, the Sicilian astronomer Pozzi discovered a small object that looked like a star through his telescope. The object became known as an asteroid, from the Greek word aster, meaning star. An impact crater like this is known as an astrobleme, literally translated as star wound. Is this a star wound in Wetumpka, Alabama? It may well be. The research continues. We've all heard of the song, Stars Fell on Alabama. Well, this song was inspired by a spectacular meteorite shower over Alabama in 1833. Author Carl Carmer, while visiting the state almost a century later, borrowed the same title in relating his impressions of Alabama as a land of special allure. He writes, "Alabama felt a magic descending, spreading, long ago. Since then it has been a land with a spell on it." He adds that the various landscapes are all part of a feeling, a strange certainty that above and around hovers enchantment. What the strange influence is or when it began is a matter for debate. Carmer goes on to explain that in the memories of some of Alabama's oldest residents, this spell, this enchantment, began the year the stars fell. Well, whether you accept Carmer's musings or not, it's clear that at times the universe has reached in to touch our state.
This program is supported by grants from the Alabama Department of Conservation and Natural Resources, State Lands Division, the Alabama Wildlife Federation, working for wildlife since 1935, and Legacy, partners in environmental education.